So this question here is question number 8 from exercise 1 of alcohols, phenols, ethers, phase 5 book. The question is conversion of cyclobutyl ethene in presence of dilute sulfuric acid into a compound B. We have to identify the number of isomeric products which are obtained. Now let's write the structure of the cyclobutyl ethene. Cyclobutyl ring and an ethene group. This is what is the cyclobutyl ethene. Now, this is in presence of dilute sulfuric acids. Now, the dilute sulfuric acid is going to hydrate, means hydration reaction. And since it is an alkane participating in reaction with dilute sulfuric acid, it is going to be an electrophilic addition mechanism. And what will be our product B? Product B should be an alcohol. The alcohol should be obtained because dilute sulfuric acid is hydrating it, providing H2O. But that happens in presence of what? Acid only. So now how does the mechanism proceed? Mechanism proceeds or starts by attack of electrophile. In presence of acid, what is the electrophile we have? That is H+. Now H+ will attack this particular double bond, or the double bond will form a bond with H+ in such a way that we'll get a carbocation. So the first step of formation of carbocation results in a cation. Secondary carbocation. Now the secondary carbocation can be rearranged into a 5-membered ring. Why we have to show this formation is the cyclobutyl ring has a greater angle strain, and it definitely any intermediate tries to rearrange in such a way that they do get extra stability. So this here is also a secondary carbocation, but it is present on a 5-membered ring now. So all of you should be keeping in mind that we are not changing the number of carbons. Whenever we are learning rearrangement, do not change the number of carbons. Here you can see 4 carbons are there in the cyclobutane, 5th carbon here, 6th carbon here. So I have maintained the same number of carbons here. 5-membered ring and 1 carbon here. That's it. So 5 carbons are only present. Now this secondary also can participate, but at the same time you already know that the secondary can undergo. Here on this particular carbon, there is a hydrogen. And we can have what? 1, 2 hydride shift. 1, 2 hydride shift is possible. As a result, which carbocation is generated? A tertiary carbocation can be generated. So, both the conditions are still existing. What are the conditions which are existing? Means in this reaction, we have possibility of secondary carbocation also, tertiary carbocation also. Now, if tertiary carbocation is undergoing hydration, we are going to get tertiary alcohol. Here the OH group comes. So that is one isomer what we have. Now, the secondary can undergo hydration. Now, the next step is OH minus. Attack of OH minus will be happening here. Here also OH minus. Now, this OH minus which is attacking on the secondary carbocation can give you cis and trans isomers. Cis and trans isomers. Because we have possibility of the cis and trans existence of hydrogen, not the other group. Please understand, it is going to be for the hydrogen. So, we can have, here is the hydrogen, here is the OH. Okay. So, this is a methyl group. And this hydrogen here can be on the same side. So, this is a cis isomer, let's say. Okay. So, along with this, what else is formed? There is a trans isomer also. Now, the trans isomer will be hydrogen and an OH group here. This is an hydrogen and a CH3 group here. So, this is a trans isomer. Now, in the cis and trans, now you must be concluding saying that there are 3 isomers formed. That's all. This is the answer. But check for the optical isomers because our question is total number of isomers. Now, if you look at this carbon here, which is having the OH group, this carbon is a chiral carbon. And here, this one is also a chiral carbon. So, similar kind of existence for the trans isomer also. So each cis and each trans is existing as two isomers, two optical isomers. To each, two optical isomers. So how many total isomers? Including of the general isomers, position isomer is isomerism, then followed by the geometrical isomerism and optical isomerism. We get 2 plus 2 plus 1. So total number of isomers obtained. Total isomers obtained are 5 in this question. I hope it is clear. Thank you.